Here, I'm going to go ahead and do printf, quote unquote, hello world, followed by a semicolon. Now, that was a whole lot of text right off the top of my head. This is the kind of muscle memory that you'll soon develop when writing a program. I've, of course, done this many times before, so I was able to just do it off the top of my head. But in a moment, we'll tease apart what all of the various lines and characters that I typed actually do. But what I'd now like to do is run this program. We conjectured last week that this is just going to print hello world. But how? Well, in the world of our Macs and PCs and phones, we would all just tap an icon if we want to actually run a program. That's not going to be the case today, because now we're in more of a traditional programming environment. The environment that we're now in requires that I use my keyboard a little bit more, or what's known as a command line interface, or CLI. This is in contrast with a graphical user interface, or GUI, or GUI, which is what describes Mac OS, Windows, iOS, and Android. But in a command line interface, I have to do everything at a so-called command line. And by that, I'm referring to this blinking prompt along the bottom of my screen. Along the bottom of my screen here, again, I described as the terminal window, where I'm going to type commands. And this is my command line interface. Anything I type here is going to get sent to this computer and hopefully execute on its own hardware. So how do I do this, and what do I do? Well, the catch, of course, is that when writing code in C or Python or Java or bunches of other languages that happen to exist, that's really meant to be written and understood by me and you, the humans. But per last week, what is the only language, in a sense, that computers understand? Brian, could we call on someone for this? What language do computers only speak? Because I think there's a disconnect between where we left off last week and where we're currently at if I'm writing code that now looks like this. Cindy, what language do computers speak, would you say?
Binary.
Binary. And just elaborate a little bit. What do you mean by binary, to recap?
Yeah, so they use ones and zeros to represent everything.
Exactly. They use ones and zeros to represent everything. And last week, we focused on only things like numbers and letters, then colors and images and videos and sound and so forth. But we didn't actually speak to built-in functionality, which computers also use zeros and ones to represent. That is to say, computers, of course, have the ability these days to print something on the screen. And that notion of printing, that function, that functionality, also is represented underneath the hood of a computer, so to speak, by some pattern of zeros and ones. Which is to say that everything I just typed, even though it kind of sort of looks like English and kind of sort of clearly says print hello world, the computer, ironically, does not know what it is I have just typed. In order for it to understand what I've just typed, I need to actually convert it to zeros and ones. And so indeed, the next step in this process is to take what I'll describe as my source code, written here in C. And last week, too, we saw source code. It was just graphical. It was those puzzle pieces in Scratch. This is my source code that, even though cryptic, is something I, at least the human, eventually can read and write. But I need to literally convert it to patterns of zeros and ones that the computer can understand. Now, how do I get to this point? Well, thankfully, we have a mental model from last week that involves problem solving. And here's a problem. How do I take source code written in this language, supposedly called C, and convert it to zeros and ones that the computer understands? Well, my input, I dare say, is going to be my source code. And my output, ideally, is going to be what we'll call machine code. Machine code is just a term of art describing the zeros and ones that computers understand. We didn't use that expression last week, but this just refers to zeros and ones on the right and C code on the left. So that invites the question, well, what is between my source code and machine code? If I take my source code and feed it into the proverbial black box, how do I get out of this black box the zeros and ones that the computer understands? Well, I need a special program that we're going to start calling a compiler. A compiler is a program that you can download for free or pay for back in the day that is a program designed to convert source code to machine code. So all I need to do if I want to actually solve the problem as stated earlier, whereby I have written this code in C and I now need to convert it to zeros and ones, I just need to give myself access to a compiler. And it turns out one of those exists within CS50 IDE. And this is a tool you could download on your own Mac or PC or the like. And for now, we're going to describe that tool as being quite simply called make. Literally, if I want to make my program, I'm going to go ahead and type make hello. And then I'm going to run it with a little bit of a cryptic syntax, /hello. But let's see that in action to tie this all together. I'm going to move my cursor down into my terminal window or my command line interface. And I'm going to literally type hello. Notice I am not typing make hello.c. I'm typing the name of the program I actually want to make. And I just want to call this program hello. The compiler is going to infer from this command that I actually intend to compile a file called hello.c. I'm going to go ahead and hit enter. There's some crazy cryptic output. More on that another day. But the fact that I don't see any big, scary red error messages is a good thing. This means that my program compiled successfully. Why? There's just no yellow or red messages to say otherwise. But now if I want to actually run this program, I need to type a different command. That's the analog of double-clicking an icon on your Mac or PC or phone. I'm going to type literally /hello. /hello essentially is like saying go into the current folder on the computer I'm using and look for a program called hello. I'm going to go ahead and hit enter, and voila, hello world. Now I see again a $sign and some other text on the screen, and we'll tease apart in just a bit what this means. But notice this $sign is just a constant visual reminder of where my prompt is, where I can type more commands. And the computer has done literally what I asked. It printed out hello world, and now it's waiting for my second command. So that was the analog of just printing hello world out of the cat's mouth last week. But surely we can do more than this. But let's tie it back to what we did last week as well, so that not everything here is all that dissimilar. So recall that last week we had functions. And it turns out we had something called arguments, even though we didn't necessarily describe them as such. So a function is like a mini program. It's an action or a verb that you can use when writing your own program that does something. We saw the say block last week. We saw the wait block last week. Those were verbs or actions, or more generally known as functions. But functions can also take inputs, recall. And we did see that last week. And nowadays, we're going to start calling inputs to functions arguments, so to speak. Another term for them is parameters, but for all intents and purposes, those are synonyms. Arguments are the inputs to functions. So let's consider then from last week this say block that we saw last time, which simply is trying to say out of the cat's mouth, hello world. Well, let me go ahead and convert this, if you will, to corresponding C code, just to emphasize how similar fundamentally these two languages are, even though syntactically C absolutely looks visually different. It turns out that if you want to say something in C using this text-based language like I just did, you're not going to write say. You're instead going to write print. That's actually a bit of a white lie. You're not going to say print. You're actually going to say printf for reasons we'll eventually see. It means print a formatted something or other. So printf is the analog in C of say in Scratch. Now notice in C, I've got this open parenthesis and closed parenthesis that nicely enough are kind of ovular in shape. And notice that they kind of mimic the white oval into which we provided input last week. So in between those parentheses are going to be my inputs to this function printf, otherwise known as arguments. But they're going to be a little different this week. Yes, I'm going to say hello world with a comma in between grammatically, just like last week. But in the world of C, I have to be a little more particular. I also have to add double quotes on the left and the right. And somewhat annoyingly, I also have to add a semicolon at the end of this line of code. So just like in English or in a lot of human languages, you end a sentence, for instance, with a period. In many lines of code you will write in C, you've also got to finish your thought, in this case with a semicolon. So this then on the right is the closest way of translating this thing on the left from Scratch to C.